Hi, welcome back to our classroom here at CSEC Math Tutor. Today we're going to be spending some time talking about inequalities. Our objectives for today are to interpret and write inequalities, to represent inequalities on a number line, and to solve simple linear inequalities. First up, we're going to talk a little bit about what inequalities are, how to interpret them. An inequality involves one of the four symbols that we have here. This symbol is interpreted as greater than or equal to, which is a double condition. This one, less than, and less than or equal to. To be truthful, the inequality just depends on where you're reading it from. So, for example, this statement here says x is greater than 1, but that is if you read it from this direction. If you read it from this direction, what it's actually saying is 1 is less than x. So these symbols, it's all a matter of where you read them from. This one is a single condition saying that x is greater than, and this one is a double condition saying that it's greater than or equal to. So it's one or two, one or the other, or both. And here we have x is less than 10, which means x is any number less than 10. Here, x is less than or equal to 12, meaning that it could be 12, it could be 11, 10, 9, 8, or any fractional part in between. We should point out here that an inequality is not the same as an equation. An equation, for example, says x is equal to 2. An inequality says x can be greater than 2. These are very, very different things. This one has a specific answer, a specific solution, and this one says any number bigger than 2 is a part of the solution. So usually, when we're solving inequalities, which we will get to later, when we have a situation like this where we say x is greater than 1, it's important to point out that this number 1 is not a part of your solution, but any number bigger than it. In this case, however, where it says x is greater than or equal to -2, then this -2 is a part of your solution along with every other number bigger than -2, such as -1, 0, 1, 2, 3, 4, etc., etc. So first, we're going to look at how to, or second, we're going to look at how to represent these inequalities on a number line. It's important for later work where we get to do stuff like optimization theory. But for now, sometimes when you're asked to do a question at CXE, the question will often say, show your answer on a number line. So how do we represent x is greater than 3 on a number line? First, we need a number line. So let's draw one. And you do not need to draw a very complicated number line. We just simply need a straight line with a 0 to tell us where the middle is. And 3 would be on this side of the number line. And so we're going to put in our x. Now it says x is greater than 3. So we need the numbers that are bigger than 3, which means 4, 5, 6, 7. So the numbers are in this direction. Importantly, when we're representing inequalities on a number line, there are some things that we use. There's an open circle that we use with greater than or less than, and there is a shaded circle that we use with greater than or equal to or less than or equal to. So these are important. So here x is greater than 3. So what we're going to use at the end of this is to put an open circle here to show right above the number that you're talking about, and use an arrow to indicate the direction in which the answers lie. So where x is greater than 3, we put the circle above 3. It's greater than or less than, one of those symbols. So we use the open circle and indicate with an arrow the direction of the answer. So this is how we would do this one. For x is greater than or equal to 6, we draw our number line. We put in our 0. 6 is on this side, negative numbers would be on that side. And so because we're using this symbol, greater than or equal to, we're going to shade that circle and use the arrow to indicate the direction in which answers are. And since the numbers are greater than 6, 7, 8, 9, etc., they go on that side. So this is how we would put this x is greater than or equal to 6 on a number line. For this one, x is less than 4. So you draw your number line. Remember, you don't need a very fancy number line. 4, x is less than 4. So we're using this thing again. So we're going to use an open circle and an arrow to indicate that our answers are going in this direction. All the numbers less than 4. That's for our number line. This one has a is interpreted as x is between this and this. So x is between -1 and 2. Some persons read it as x is greater than -1 and x is less than or equal to 2. It's much easier to read it as x is between -1 and 2, inclusive of 2. So when you draw your number line, we have a -1 over here, we have a 2 over here, and we're going to need 2 dots. On this side, it's greater than -1, so we use an open circle. But on this side, it's less than or equal to 2, so we use a shaded circle. And since it's between, then we simply use a line to connect these two. And this is how we would put this on a number line. For this one, x is between 2 and 4, or x is greater than or equal to 2 and less than or equal to 4. So just saying x is between 2 and 4, inclusive of those two endpoints. So we draw our line, we put in our 2 and our 4. That's our number line there. And since we're talking about 2 and 4 and both have the double condition, we need to shade those two circles. And once you shade them there, then we're talking about all the numbers between, and so we'd simply draw a line to connect. So this is how we'd represent each of these in a number line. That's for A, this is for B, C, D, and E. Just writing that there to differentiate them, so that persons don't get confused as to which one is which one. We can do the opposite of this now. We can take a number line and reinterpret it as an inequality statement. So remember, the open circle refers to greater than or less than, and the shaded circle refers to greater than or equal to and less than or equal to. In some textbooks, such as American textbooks, sometimes they use an open bracket like these to represent this symbol, this greater or less than symbol, and a square bracket like this one to represent this condition. So if you come across it in a textbook, such as a textbook dealing with Algebra 1 or Algebra 2, as the Americans use, then this is what they tend to use on their number lines, the brackets here, which would mean this, and this type of bracket, which would mean that. So here, we're going to change these to inequality form. So here we're saying that the numbers start at 1 here, they go in that direction, so it's less than 1. So we're going to write it as, in this case, x is less than 1. That's part A. B, the numbers in this case are -2, 1, 0. So the numbers here are bigger than -2, but they also include -2. So we would write that B as x is greater than or equal to -2. For C here, the number lies between these two. So we would have -2. This number is not included, so we need to use the less than sign. The x goes in the middle, and on this side we are including that too. So we need to use that double condition to represent it. So we put the other 2 up here. So we read it as x is between -2 and 2, inclusive of 2. And this one, D, notice that both endpoints are of this type, greater or less. So we use our -1, we open greater than sign on that side, and here we put in the 3. Notice something, please, that when you're writing your inequality signs like this, that they must be turned in the same direction. So you cannot have one turn this way and then the other turn that way. They have to be in the same direction. So pay attention to this, that they're in the same direction. All right. Okay, here also that they're in the same direction. Same thing with this one at E. So we are looking at -1. X is between -1 and 3. So we start at -1. X is bigger than that, but x is less than or equal to 3. And so we use that double condition to represent this one. So we can take a statement given on a number line, a diagram, and interpret it in terms of an inequality, or we can take an inequality and put it on a number line. Now let's talk about how do we solve inequalities. And when we solve inequalities, what we're looking for is not a solution, but we're looking for rather a solution set. That is the set of numbers that will satisfy this inequality. Inequalities are solved in the same way that you would solve a regular equation. All the principles that apply to inequalities, to equations when you're solving them, apply to inequalities. So here we have n is greater than 2 minus n. So we are going to reorganize this equation by grouping like terms. This minus n would be grouped on that side with that other n. So we would group it as n plus n, do the opposite of this, is greater than 2, which means that we have 2n is greater than 2, and dividing by 2, let me just move this a little bit. Dividing by 2, we end up with n is greater than 1. So any number that is bigger than 1 would form a part of this solution. So notice that 1 wouldn't work, because if you put 1 in there, then you're going to have 1 is greater than 2 minus 1, and 1 is greater than 1, which is not true. This is not a true statement. But any number bigger than 1 would work, such as 2. 2 is bigger than 1. So if we try 2, 2 is greater than 2 minus 2, and 2 minus 2 on this side is 0. 2 is greater than 0. This is a true statement. This is false. This is true. So you know that your solutions actually lie in this direction. Any number bigger than 1 would be a part of the solution, and there are infinitely many of those solutions. So sometimes when you do a question, you might want to check your answer to make sure that the numbers that you choose are actually the numbers that are needed. Here we have an equation, an inequality rather, with the unknown on both sides. We go through the same process where we reorganize the equation by grouping like terms. So here we're going to have x, regroup this minus 2x on that side, gives us a plus 2x, is less than 10, keep that 10 there, and regroup this minus 1 on that side, so it becomes a plus 1. So what we have now is 3x is less than 11, and now we divide by 3, so x is less than 11 over 3. So it's the same idea. Any number less than 11 over 3 would work for this question. So let's look at some other examples. Here we have one that says 3x minus 5 minus 5x is less than 7. So we are going to first solve this, and then part B says copy the number line and draw your solution set on it. So let's write down this first. We have 3x minus 5 minus 5x is less than 7. So let's organize it a little bit. 3x minus 5x and this minus 5 needs to be regrouped on the other side, so it's less than 7 plus 12, plus 5 rather. I'm thinking about the answer before writing it down. So we have a plus 5. This is a minus 5. Once it's regrouped, it's a plus 5. So here we have a minus 2x is less than 12. Now, if we follow this, and I need to follow it to show you that the importance of checking your answer. So let's check it. Let's continue it without this the way that we would normally do, divide by -2. So it would tell you that x is less than -6. That's what this says. That's what the mathematics of it says. X is less than -6. So a number that is less than -6 would be a number going in on the other side of -6, going that way. So anything less than -6 would be going this way. So let's pick -8, for example, and test it. So if x is less than -6, then using 8, we're going to use -8. 3 times -8 minus 5 minus 5 times -8 is going to be less than 7. So if our answer lies there, then the statement will be true. So -24 minus 5 minus 5 times -8 is -40. So 24 minus 5 is -29 here. -29 plus 40 greater than is less than 7. All right, less than 7. And immediately 40 take away 29 would be 11. And here we realize there's a problem. 11 is not less than 7. So this is false. So we solved it. We didn't make any errors in terms of the mathematics of it. But when we test it, we realize that our answer is not true. X is not. The solution that it says x is less than -6 is not true. This happens for a unique reason, and I'm going to point it out now with this. Whenever you're solving a question and you notice that you end up dividing by a negative, when you write your answer, you have to reverse your inequality sign. So once you're going to divide by a negative, you have to reverse your inequality sign. So here we are dividing by a -2. So the question says, once we get to this point, let me just put that over here, we end up with -2x is less than 12, which tells you that you're going to be dividing both sides by -2. Once you end up dividing by a negative, x is less than -6, you must reverse the direction of this sign. So your answer should actually be, once you end up dividing by a -6, your answer should read x is greater, because you're going to reverse this, change the direction of it, -6. And all the numbers that are greater than -6 would be like -5, -4, -3, -2, 1, 0, 10, 20, etc. And if you try that, then you will realize that your solution, your answer is going to be true. So pay attention to this kind of question. If you come across a situation where you have to divide by a negative number in solving an inequality, remember to reverse the inequality sign. So we have to reverse that sign. All right. So since x is greater than -6, we put our open circle above -6 and indicate the direction where our answers should go, and that is where our answers should go. All the numbers in this direction would be a part of our solution. -6 is not. All right, let's try another one. Here we have 2x is less than 14 and 3x is less than 14 is less than 3x plus 5. When you have a question like this, when you're solving it, you have to split it in two. That's the best way to do it. The best way to do this kind of question is simply to split it in two. So we're going to take this part. Let's highlight it. We're going to take this part as 1, and we're going to take this part as as 1. We have to split it in two. So we end up with 2x is less than 14. That's from this one. Maybe I should write it in red to keep it 2x is less than 14. And here on the other side in green, we have 14 is less than 3x plus 5. So here we can solve this one. We are dividing by a positive number. So we can simply say that x is less than 7. That's fine. On this side, we need to reorganize it, put the numbers on one side. So 14 minus 5 would be less than 3x. 14 minus 5 is 9. So we have 9 is less than 3x. And we divide by 3. So 3 would be less than x. So we have two things here. It says x is less than 7 and x is greater than 3. So our solution forms within the band. Let's put a number line. 3 and 7. So this is our number line. X is less than 7. X is greater than 3. So our solution would lie between these numbers. So any number between 3 and 7 should work. Let's test it with 1. Let's use 4 just to see if it works. Since 4 is between 3 and 7. Now when we put 4 into this, let's see if this statement comes out to be true. So 2x is less than 14, and that is less than 3x plus 5. If x is 4, then 2 4s are 8, and 3 4s are 12, and 12 plus 5 is 17. So this is a true statement. 8 is less than 14, and 14 is less than 17. So any number within this range, within this group, between 3 and 7 would be a part of the solution. Sometimes CXC will ask you to write down, for example, the whole numbers that would work, the integers that would work, and so you sometimes those little things can trip you up when you don't remember. It says write down the whole number solutions, write down the integer solutions. Pay attention to those little things when the question asks you to write down your answer, so that if you have to write it down, then it will become a simple thing to answer. But this is how we do it. If it ends up being like this, and this is actually a question from a past CXC paper, that you split that question in two parts and solve it in two parts. And once you do that, you would end up with your answer, which in this case turns out to be any number greater than 3 but less than 7. And you can write that as the union of both. There's one last example that I did not mention here, but we need to put it up. So let's put it up there and have a go at it. Sometimes a question may be written as solve. 12 is less than or equal to 4x is less than, let's say 15 for argument's sake. And to solve this kind of equation, we simply need to divide through by 4. Pretty simple. So this is our 4x in the middle, so we divide by 4. And in dividing it out, we end up with 4 into 12 goes 3 here. Is less than or equal to, that divides out and gives you your x, and 4 into 15 gives you 3 and 3 over 4. So this is how you would approach a question like this. There's no need to split this one. There's only one place where x is, it's in the middle, so we just divide through by 4. And that is how we solve simple inequalities. That's how we represent simple inequalities on a number line, and how we interpret them when they're already on a number line. Thank you for watching.